Hi, my name is Eloise. We have Cindy and Gerard joining us again today. Hi guys.
Hi Eloise. Hi everyone.
Hi everybody.
In this lesson, we will use our geometry knowledge to help with some plans for building houses. To do this, we need to investigate the area of different quadrilaterals.
Eloise, I think applying our geometry to housing plans is a great idea. It sounds like fun.
Well, let's see what the problem is. A team of property developers is planning a low-cost housing development. The 4 pieces of land they want to sell are all equal in area. All the plots must have easy access to the road, and they also want each plot to look onto the river on the other side. The plans look like this, and the developers can see they've got a problem.
I see their problem. The house on the end has no river frontage. They need to give all the buyers road access and river frontage.
Is there an answer to their problem? Can we help them with our geometry? In this lesson, we will make and investigate conjectures about the areas of shapes. Then we'll come back to the property developers with our suggestions. By the end of this lesson, you should be able to make a conjecture about the areas of shapes. Okay guys, how do you think we can help them?
Maybe we can change the direction of the river.
Get real, Gerard. Next thing you'll want them to move the mountains.
Guys, what about geometry? We haven't been given the exact areas of the plots, but we do know what they look like.
They've made all the plots rectangles. Do you think we could change that and then perhaps change the shape as well?
Why not? Let's shift these rectangles. Push them over a bit to make parallelograms. Like this.
That could work. But wouldn't it change the size?
I'm not sure.
Guys, your idea is good. But to check the plots will still have the same area if they are made into parallelograms, you need to use maths. You should have some square dotted paper on your desk. This will make it easier to draw your rectangles and parallelograms. It doesn't matter what size you use to work out the problem. If your idea works on paper, the developers can use it for their plans. Dotted paper is like squared paper. The distances between the dots are all the same. So we can call the distance between any 2 dots 1 unit.
Let's just look at one rectangle. If our idea works for one, it should work for all 4. Say this is one of the plots.
How are you going to shift it?
Well, I'll keep this line where it is now and draw in the parallelogram like this.
It's looking good, guys. But before you go on, it will help to label all the vertices of the rectangle and the parallelogram.
Good idea.
Okay, now how do we find out if the red rectangle and the blue parallelogram have the same area?
The area of a rectangle is length times breadth.
Isn't it base times height?
Actually, you're both right. If you look at a rectangle, the breadth can be called the perpendicular height and the length can be called the base. The base and height are perpendicular because the angles of a rectangle are all right angles. So the area of a rectangle is length times breadth or base times height.
Then all we have to do is count the spaces between the dots along the base. That's 6 units. And the height, which is 5 units. So the rectangle's area is 6 times 5. That's 30 square units. And now for the parallelogram. The area of a parallelogram is base times height. The base is the same as for the rectangle because we didn't move it. So that's 6 units.
And the height is the perpendicular line BC over here, which is 5 units again. That gives us the same answer, 30 squared units. So our rectangle and our parallelogram have the same areas.
Yes, but we haven't solved our housing problem. We've only shown that these two shapes have the same area.
So what do we do now?
Okay guys, you want to be able to convince the developers that they could use parallelograms for each plot instead of rectangles. But you need to give them clear information about the length and the breadth of the shapes. In other words, under what conditions can you be sure that a parallelogram and a rectangle have the same areas? Let me show you what I mean. Here is a rectangle EFGH and a parallelogram EHJK. They both share the same base EH. The area of rectangle EFGH will be 2 units times 9 units. That gives us 18 square units. And the area of parallelogram EHJK is 2 units times 11 units, which gives us 22 square units. Obviously, these two areas are not equal. The shapes share a common base EH, but their heights are different. So how can we change EHJK to make the areas equal?
If we draw JK in here, then the height will be the same as the height for the rectangle. And the area for both the rectangle and the parallelogram should be the same.
Well done. So what do you think are the conditions needed for a rectangle and a parallelogram to have the same area?
The rectangle and the parallelogram must start on the same base and end up on the same line on the other side.
So in other words, they must be between the same parallel lines.
Great stuff. Now, can you use these ideas to make a conjecture about the area of a rectangle and a parallelogram? Remember, a conjecture is a statement that seems to be true, but is still just an opinion or an idea. It has not yet been proved to be true.
We're still not clear how to get going with the conjecture.
Yeah, can you help us?
Sure. A useful way is to use if and then. So you could say, if a rectangle and a parallelogram have certain properties, then we find that there are other true conclusions we can make.
Let's try that. We can start with the then part because it's easier. We can say, then the areas are the same.
And for the if part, we could say, if a rectangle and a parallelogram have the same base
and are between the same parallel lines. We've got it. If a rectangle and a parallelogram have the same base and are between the same parallel lines, then their areas are equal.
Excellent, guys. Well done. You've included the two premises, the if conditions that lead to one conclusion. If a rectangle and a parallelogram are on the same base, and if they are between the same parallel lines, then their areas are equal. But you've shown that this is only true for the particular rectangle and parallelogram you've just been working with. You haven't proved this conjecture is true for any rectangle and parallelogram. Let's not forget, we need convincing proof for the developers. The people who are going to buy the plots from them will want to know that they're all going to get the same area of land. Until you're sure that this conjecture is true for all cases, you can't really take this idea to the developers. So we're going to ask you to work on finding a proof about these areas. Write down a plan for the proof of this conjecture, that a parallelogram and a rectangle on the same base and between the same parallel lines have equal areas. In this lesson, we've made good progress towards establishing facts about the areas of a rectangle and a parallelogram. Next time, we will continue with our investigations and find ways to prove this conjecture. We will also write down this proof in different ways.
I'm looking forward to that. I can't wait to show the developers our ideas.
Me too. They'll be so impressed that we used our geometry to help them.
So, make sure you join us next time.